Alright, due to the emphasis of equipment, tool availability, and productivity, preventive maintenance is a key and essential element in the overall success of any manufacturing company. With that said, we're going to start off with the wet clean. The wet clean is comprised of 4 vital parts, which will all be broken down into individual tasks. And those parts include the preparation stage, the lower wet clean, the upper wet clean, and the recovery process. Starting with the preparation stage. First thing you want to do, you want to order up your clean O-ring kits from your supply department. Once you've ordered up your kits, you can then start AutoPM, which is an automated checklist that is found on the equipment software. After you've started AutoPM, you can now proceed to your lockout tagout regime of it, which is your energy isolation procedures that consist of cutting off your AC circuit breakers as well as your RF generators. So after you've finished prepping the chamber for the meat and potatoes of this scheduled maintenance, which is the upper clean and the lower clean, we can now proceed on to the upper clean. And the first thing you do in your upper clean is that you want to vent your chamber, which simply means that you want to make sure that the chamber is safe enough to expose to atmospheric pressure. Once you've vented your chamber, you can then move on to mode 2 access, which gives us access to the upper chamber hardware. And what we're going to do after we got into mode 2 access is that we're going to raise the upper component using an electronic hoist, and then we're going to turn that component 180 degrees to kind of isolate it from the chamber. That way we can get into it and start working. Once we've isolated that upper component, we can now start to remove hardware, remove and replace the required O-rings, and after that's done, we can start putting everything back together again, start the reassembly process. So after our reassembly process, we can now move on to the lower clean, which is really the second half of this clean here. And the first thing we're going to do in our lower clean is that we're going to stop our turbomolecular pump. Reason being, this baby moves at 37,000 RPM. Boy, 37,000 RPM. And that is what's used to achieve our super high vacuum state from within the chamber. So after we've stopped, completely shut off and spun down our turbo pump, what we want to do then is move into mode 1 access, which gives us mode 1 operation, which gives us access to the lower chamber hardware. So once we've gotten that access, we can then isolate the lower chamber and remove and disassemble any hardware that we might have to disassemble in order so we can replace our O-rings, which create our sealing surfaces, which prevents atmospheric air from entering our chamber's vacuum state. So once we've replaced all our O-rings in our lower half, which includes our focus rings, our quartz rings, our edge rings, our vat valves. Once we've replaced all of those O-rings, we can now start to reassemble the lower half of the chamber. Once reassembly is fully complete, we want to then go over both the upper and the lower halves of the chambers. We want to go over those with 100% IPA, inside, outside, our sealing surfaces, everything. That way we can sterilize our sealing surfaces. Once we've done with this sterilization process, we can now move on to our recovery process. And the first thing we do in our recovery process is we run 30 pump purges, which completely eliminates any contaminants or particles that may have been left behind during the maintenance. After our pump purges are complete, we can then move on to our O2 burn recipe. And what that is, that's just a process that is composed of an oxygen plasma that's used to dry out our chamber of any other fluids or contaminants that might be in there, such as sweat, alcohol, or any type of condensation that might have accrued during the maintenance plan. So once we've run our O2 burn recipe, now we can check our leak rate. And like I said earlier, your leak rate is just it's a measurement of how much the chamber leaks atmospheric pressure into its vacuum state, which pretty much tests the integrity of your O-rings or your sealing surfaces. So once we've ran our leak rate and we got a good leak rate in, then we can start checking the system's calibration devices and switches and checking those for malfunctions. And once those diagnostic tests are done, we can then move on to test the chamber to see whether or not it can actually etch wafers properly and successfully. And once we've accomplished this, we can move on to the post-recovery process, which then is we return back to our supply department all of our used parts, all of the old O-rings, and then from there we can start to annotate our proper documentation, things such as our checklist, our kit cards, our labels, and things of that nature. So once you fully return your kits and cross your T's and dotted your I's, your full wet clean is primarily done now. Now you can return the product into a productive state. And I guess in conclusion, pretty much what we said here is that our full wet clean consists of 4 vital parts, and they are the preparation stage, the upper clean, the lower clean, and the recovery process. And pretty much what the preparation stage focuses on is the energy isolation procedures as well as the safety aspect of the maintenance. The upper and the lower clean pretty much are the hands-on sections that cause for you to remove and replace chamber hardware and O-rings, and the recovery process is the last process prior to logging a tool up to a productive state. And pretty much that's what you have in a nutshell.